Now, how to get the directions is what I just brought it only to how that acceleration of sphere, how the friction will, only for learning purposes, how to get the various accelerations and forces that will be acting. That was the only purpose of this particular problem. This inclined plane is fixed. This is small m, capital M. Cylinder of cylinder is having mass m. Okay, try this one. Okay, I'll come into the picture. Just only learning purpose. I feel like, okay, it's a good problem where the how the direction various forces that should be acting. So the moment will release the weight of the weight mg will act down. Okay, these are the masses capital M. We'll make it m to m1, so that symbols will not get confused. And the mass of this also m2. Let's proceed into this one. How the tension, so the moment I release, so here the tension, so called this is T1. The weight m2g sine theta. What to decide now? It's telling it the system is from that find the condition that m equal 4m, the acceleration of the Planck is. Okay, further some relationship is also there. Quotient of friction between cylinder and the Planck is sufficient for pure rolling of cylinder. I think this is the very important part of the whole question. This sentence is very important. Now we'll see. It should roll. Will it roll down or roll up? Anybody wants to say cylinder, will it roll up or roll down? Okay, one. Manijip, okay. You are saying some. Anybody still? Because I want your what actually going on your mind. Roll up or roll down? See if it rolls up. So what is the thing? This string will be taut, no? So you look at this one. This string should be taut and inextensible. I'll get the thing. No, and also should be inextensible. There's a primary condition, no? I think now you start with this condition. Whenever the strings comes in the rolling body, whenever a rolling body is connected to string and the body is rolling, no, look at the strings. Strings must be taut and inextensible. Keep that in mind. Now proceed here. So I'll first will show other forces that are acting. I'll come to the acceleration. I think this is as usual m2g sine theta. So the tension, I think string will be taut. So tension will act here. So this tension is what we'll call T2. So then the friction, I'll put it here. So the acceleration of this should be in this direction. And alpha 2 should be in this direction. And the acceleration of Planck, A0, I'll write it. I think that the acceleration of this should be equal to acceleration of this one. Symbols, A only, I'll write it. That'll be better. Sir, how you are assuming? So like, I think this is the primary for me now. The string, the acceleration of this point is 0. So acceleration of this point should be 0. So therefore A2 minus R alpha 2 here. The acceleration of this point should be 0. From there, continue to come. Then at this point, no slipping will occur. Then A2 plus R alpha 2 should be equal to A. There's an equation at this particular thing. Rest all everything will write. So here is what we do forget. The acceleration of this point should be 0. So I think this is a very fundamental. I'll indicate like this P2. This, okay, I'll write P2 will write P1. Acceleration of point P must be 0. Why should be 0? Because for the string, it should be inextensible and should be taut. That's the only reason. So therefore, A2 minus R alpha 2 is equal to 0. Then acceleration of point P2 should be equal to acceleration of point P1. Acceleration of point P2 will be, acceleration of point P1 is equation 1, 2. Rest all everything now very easy. Huh? Please do give importance for the constraint equations because they matters a lot. Now, sir, how you are assuming friction? How you are assuming friction? Okay, fine. Okay, everything you are showing something. Tell me, like, what about the frictions? How you decide friction? So tell me, like, for alpha, is it direction of friction? Shall we put this upward, this downward? So why you're taking this friction downward? Why can't this be upward? There's also a reasonable question, no? Nothing wrong if some student asks. Or shall we solve problem? If I get F negative, I'll change direction. Okay, can we take a risk like this? Okay, we'll do one thing. First, we'll proceed like this here. The moment we release, this is 4m, this is m. So this will be 4mg sine theta, theta 30 degrees. So this will become around 2mg will act here. This is mg. So this will try to slide the Planck. This will oppose. So friction will act here. There's a one reason what I can justify. Now, what about circle? Let's come for you. The moment you release, mg sine theta will act. Mg sine theta will act. String will become taut. Then torque will be acting. Then torque will act and it will make it to rotate. So then that friction should act upward. Then the friction on the Planck should be downward. Because the moment first like this will slide or rotate. So first what actually happens? This will slide. This will actually the motion will take place from here. So the moment you release, the plank will try to slide. Then the rolling will prevail in this particular thing. So therefore, I should start with the plank here. So what happens if I take in this direction, I'll solve it. You'll get wrong answer. Then sir, in exam, yes, I think these are some difficulties what you may face problems of 2 or more rigid bodies when they're in contact. Predicting the direction of friction is a little bit headache. You have to be extra alert here. Okay, let's write down all the equations. So m2g sine theta plus f minus m2 e2. Then torque F into R plus T2 into R is equal to C, I'll write it, IC alpha 2. I think all the equations over. Yeah. Then for the plank, M2G sine theta minus F minus T1 equal to M2E. Then T1 minus Mg equal to M1E. Solving all this, we'll get the required thing. And what we have information is M is 4M, no? So here M2 is in fact 4M1. You have to solve. I didn't get time to verify the answer. The acceleration of Planck is asking, no? I think 5 will come. Check it. I'm making 50 by 20. Okay, make observation. I'll slide down. We'll go to the next problem. Take this question. Yeah, very. Look at the pivot and some particle is there.